Okay, welcome to week 7. We're going to start by reviewing saving for retirement, and hopefully this will be good. Some people were having funny attendance last week because of colds and kids having colds and things, so we're all here. This is good. We talked about percent sentences. They have is, of, what, and percent, and there was the translate way and the proportion way to solve them. And the end product of all of that was this cute little picture, which I will make bigger, where you have something is something percent of something else. You have some word problem in real life, and you have to figure out what is the part to change the new amount. You have to figure out what is the whole, the original, the baseline amount. And then it's sort of like Mad Libs. You plug them in and use either the translate or the proportion method, whichever makes you happy. All of that ring a bell? Okay. Since it doesn't actually happen in what we're doing later, I'm not going to review it now, but at the end of class, if anyone wants, I can do more of these. But we've done a bunch of these, maybe even enough of these. So this allowed us to build the concepts we wanted to get the formulas. So we talked about percent change. I finally have a new section about percent change, which I'm going to tap to put in the paper, the PDF notes. So percent change, when you do the same thing we just did with the Mad Libs, it will always turn out to be that percent change is change divided by original. So that's just a good shortcut. I know we've used it before. It wasn't actually given enough prominence in the lecture notes, so now there it is with a subheading and everything. Okay, all of that was just sort of getting our brains ready for talking about interest by thinking about percents and thinking about percent changes and thinking about percent sentences.
So is this for saving for retirement?
This is the beginning of the saving for retirement. We haven't done any saving for retirement yet, but this is sort of the Math 20 review, that the ideas you need before you get into the new stuff. So then we actually started. We had interest, and we talked about interest. We later on would talk about appreciation. They are slightly different. If your investment is earning interest, that's a fee, right? You are paying the credit card company a fee, or the bank is paying you a fee for borrowing money. Appreciation is just things get more valuable over time, or depreciation, they get less valuable. If your car goes down in value and your house goes up in value, it's not that there's some fee being paid, that's just how it is. But the simple interest idea can work for both. We have Kim's favorite, the 1+ trick. If you want to do a percent change and keep the original amount, you can do it in 2 steps. For example, 100 times 0.12 is $12, and then add it back on to get 112. Or you could slam a 1 in front of the 0.12 and get 112 in one step. And we needed this for the compound interest formula because we were repeating something a lot, and we could only repeat one step a lot. It wouldn't work as a formula to try and wibble-wobble repeating 2 steps back and forth a lot. That pattern would be harder to see. Okay, simple interest was principal times annual interest rate times years. Simple interest is always everything about years. The hard part about simple interest is when they give you a number that's not in years, because it has to be in years. So then we have to fuss with it. So let's actually do our first review problem from last week. Oops. Come on. What am I trying to do? That's what happened. And I'm just going to grab one from the practice final. I'll write it in black. I'll put that up there. Okay. Some people will abbreviate it as P times R times T, principal times rate times time. That's popular enough. I will do it just so I have both on the board. And for all of these formulas, my recommendation, again, is don't jump and plug things in. That's where people are going to make mistakes. The formula is really easy. The calculator does all the work. The hard part is knowing what to plug in what spots. So I'm going to list out all of my letters. So I can think about them before I plug them in. In this case, the interest rate is what we solve for. The principal is $3,000.82. The rate is 19%. And I'm going to need to change that into a decimal. So I'm going out of percent. And my time is 114 days. So again, with simple interest, everything needs to be in years. The interest rate is already annual. It is per year. We're happy with that. But my time is not. So how am I going to change days into years? Yeah. If you want, you could make a decimal. If you want, you could write a fraction. If you want, you could not simplify it at all and just leave it as 114 divided by 365. I'm going to do that last option just because I'm old. My calculator can handle fractions with the fraction button, no problem. I can take a decimal and have enough digits displayed it won't affect the answer by rounding in the middle. But just by my habit as an old fogey, then I'm going to leave it like a division problem, because then I don't round in the middle and I don't have a fraction, and that's what my brain likes. But all three are good options. Okay, we've done our fidgeting. Everything is per year. Per year, per year. Right, we're happy. Now we can plug things in.
So I have a question.
Sure.
How you have that wrote out 114 days divided by 365.
Yeah, so this is
So
days per
it's
year.
not 365 divided by 114.
No, other way around. Why can't I? Days per year. Yeah, division, it matters which way we do it. We can't go 365 divided by. So whatever this is, $182. Whoops, wrong color. 89 cents. Everyone get the same thing? Your calculator does. Let's see.
So when I divide 114 days divided by 365, that's what I get.
Yeah, only the times 0.19 times 2082. So what you did oops. because you left this as a decimal. I'm not sure why that jumped in. Oh. So, did it work now?
Yes.
Okay.
Thank you.
Okay, sometimes these are as straightforward as that. We had to fidget with the days and the year, but other than that, it was pretty easy. Sometimes they're more complicated. Let's look at the next one. So in this one, we're solving for something else. It's still true that I have the same setup. I can just grab this. Now, the interest is going to be $4.08. Where did I get that? Yeah, we had... So she writes her post-dated check for that amount. The loan was that amount. So the difference between them must be how much the interest is, because she's not going to pay the payday loan company anything but the loan or the interest. Okay. And minute check is there. Some way to make it less. No, not language. Table line smoothing, maybe that's what I want. Okay. So the interest is that. The principal we knew. The rate, that's what I'm solving for. And the time is 20 days. Okay, what's my next step? Yeah, again, somebody was rude, didn't give me years. I have to make it. Do you want the decimal, or do you want me to just have the 20 divided by 365?
I can fraction myself.
Like that, okay. I'll pick the decimal then. So 20 divided by 365 is about... Okay. Now we're ready to plug things in. We look for years. This one's in a year. This one, well, we're solving for it, so we can't fidget with it. Everyone okay with my blue stuff? That's the confusing part. Now I'm just plugging things in. Okay, I have my R in the middle. How do I get this R by itself? No. If all I had was multiply by 355, how would I get R by itself? Divide by the 355. That makes sense. So we'll start with that. We'll divide both sides of the equation by 355. Keep drawing my fives. Okay, so what do we have? 4.08 divided by 355. I'm rounding there. Okay, we're getting closer. Now all I have is something stuck on the R with times 0.05479. How will I get R by itself? Someone other than Amanda. Yeah, exactly the same as before. Something stuck on with times, I divide by it to get rid of it. Thank you. So now I finally have R by itself, divided by 0.05479. Okay.
0.02. Did I mess up?
Anything you messed up?
0.01149 divided by 0.5479.
It's not 0.5, it's 0.05.
0.05. Okay, thank you.
Okay, are we done? We have R.
No.
Now, what do we need to do? Yeah, it asked for a percent, a rate. So now I'm going to go into percent. And I'll probably round it again because that looks like it really wants to be 21%. Yes?
So I got the same thing, but I did a little bit differently. I multiplied the 355 and the 4.
That works too. Yes, that works. Let me go back up. So what Tricia did is, when you have these three items multiplied together, it doesn't matter what order you can do it. So she effectively said, I'm going to just treat those, have a multiplying of things here, and then divide by that to get the R by itself. But since that's kind of an extra step that's not officially from Math 20, that's an algebra kind of thing, then I'd rather do R step twice than introduce something new. But that's good too. Okay, questions on this? This is as hard as we can make it for simple interest.
Will you go to the very bottom again?
Sure.
Okay, all right. Well, you have 0.2098 and I have 0.2093.
We might have just rounded differently in an earlier step.
Okay.
Okay, do we need more simple interest ones after this, or is this enough simple interest review? I hear only okays or no comments. Okay, so simple interest, again, as a situation, is when some money is invested, like you buy a bond, you don't get any payments, nothing happens, it just sits there dormant, like Rip Van Winkle, until it wakes up at the end, and then you get your money back, and you get some interest. So there's only one payout at the very end, even if it's a 5-year bond or something like that. Okay, the next situation was compound interest. We did this chart over here where we talked about the pattern that happened. I'm not going to review that again, but we wound up with the formula where typed out, oh no, I can't even paste it because it gets rid of the exponent. So I will write it big on the screen. So you take your principal, you add 1 to the rate with that 1 plus trick we briefly mentioned earlier today, and then the exponent is the number of payouts, and that S needs help. Just like with simple interest, plugging things in, once you have it plugged in, the calculator does all the work. The hard part is the setup. So we're always going to talk about the things. What is the total amount? And principal. And the rate per payout. Number of payments. Okay, so I'm going to copy this because we will use it many times. The compound interest situation was that we put in money just once, or borrow money just once on a credit card or something. And then there's repeated payments of interest that happen. Every month we pay our credit card interest. Or every quarter our stock gives us a dividend or something like that. Whenever that happens, the interest that is added will be part of the debt and earn even more interest. So, let's look at a problem. Actually, I'm going to move this part down. Paste our problem at the top. Oh, okay. Oh, oops, all of that. So he invests $3,000 and he lets it grow for 12 years. The account earns 2% compounded monthly. And at that point we're going to stop because that's like part A of the problem. So we're just doing part A. Next slide, we'll do part B. On there. Okay. So as before, the blue words are the tricky part. The total amount, that's what we're going to solve for. The principal was 3,000. The rate per payout, it's 2% per year. But we need things to be monthly. So how am I going to switch from per year to monthly?
Divide that by 12.
Yes, I have to imagine we're dealing out cards. I have to share the 2% among 12 different pieces. Then the time was 12 years. Again, it's compounded monthly, green circle, so we don't want any of these things to end up in anything other than months. So how do we change 12 years to make it how many months there were throughout the whole time? Yeah, times 12. So every year we have 12 months happening. This will often happen in compound interest problems where your two green numbers are the same. If it's monthly, it'll be a divided by 12 and a times 12. If it's quarterly, it'll be divided by 4 and times 4. If it's weekly, divided by 52 and times 52. Everyone okay with all my blue fidgeting? Again, this is the hard part. This is where people make mistakes. Now this formula looks a little scary because of the parentheses, but they actually aren't there. Oops, I can spell the word amount. Amount, there you go. So the principal is my 3,000. And I'm going to multiply it 1 plus the rate per payout. So all I do is I take this number and I put a 1 in front of it. Does that make sense? I'm adding 1 to a tiny decimal. To actually use parentheses and stuff is overkill. And then my exponent is 144. In my calculator, I can't do a little bar over the 6 to tell it to repeat it forever. I'm just going to pound in a bunch of 6s until I fill the screen. It'll be close enough.
So we can't just round it up from.
Now, if you don't have any extra 6s, you're going to get off by a few cents.
Rounding the 117 is too many.
Yeah, especially for 12 years, that might not be that big a deal, but if we have a longer time frame, it gets really noticeable. So, it's not going to change, like, is this person ready to retire? But it'll be off by a few dollars. The mafia will get upset and come after you.
Well, I came up with 3,004.9999.
So, okay, well, let's type this in and see. Now, if you weren't here at the calculator exponent day, you have a calculator button that looks either like x to the y or y to the x, or a caret symbol. And no matter what button you have on the screen, it's going to look like the caret symbol. There's another button.
I can't use it. I can't get it to work at all.
Okay, I'll come over in a moment.
And
There's
it
a-
makes me feel today, 'cause I don't have to do it.
That it should still do it. The display will always have the caret symbol, and there is a button that says EXP, but don't do that one. That's scientific notation. So what I'm going to type in is 3,000, then times, then my 1.001 and as many sixes as I can. And then I'm going to do my y to the x key, or whatever your key is, and then my 144, and then my equals. Does that make sense as a steps? Let's see what we get. And then I'll come around the room. So $3,812.99. Did I hit all my buttons right?
So if I take that each, like I use this one for, but I type in, but if I clear it like a million times, but if I click anything, it'll do, but it like always adds something or does something. I have one, but I don't know what it is.
Okay. Your calculator's happy.
I think
Your calculator's happy.
Like 4 months. Okay.
Yeah.
Sorry. Okay.
So there we go.
There's a difference of like $20-something if you
If you made it
round.
1.7.
Yeah.
Okay, we aren't actually done with the whole problem. This was just part A, but this is sort of a complete problem. Right? We've done the compound interest formula. Questions about this before we move on? I'm not normally going to write out the calculator button step, but
So we did y equals times 144?
No.
New type.
Yeah.
use the multiply button here and the y to the x button here.
Okay, okay. Thank you. That's the part I'll forget.
Yeah. So I want to walk around and make sure it works now. Because I've had people text me screenshot or photos of their calculator from home saying, I'm trying to do my homework. Where's my exponent button? Easier to get it.
That's a good idea. I'm always afraid of bothering you, so I just wing it and get it wrong. No, I run on break my crops and call in the middle of the night.
Okay, so now we've done this part. Now we're on part B. I've never actually had anyone try calling me in the middle of the night. And I
And
try.
I, the person that said call in the middle, said call when he needed help or something. I was giving you problems.
Okay. So, total amount. Oops, what happened with that? Starboard, where'd you go? Yes, I want to recover data. You don't need a blank page. Do we have everything from before? we just lost that slide. That's terrible. Okay, well, I'm going to save it just in case that happens again. I'm not sure why my little R is floating. My S. And we needed an N in amounts. Okay, do you want me to fill this in real quick? Anyone not trust their own notes enough? Yeah, okay, we'll try and speedily fill it in.
Oh, I thought you meant for the next problem that we're doing.
Solve for, so this is part A. That should be green. As long as I am redoing this, then I will show you a different way to press buttons in case it makes you happier. Okay, so before, in the blue area, we made a single number for each of these, because that was the easiest to plug into the calculator. If instead you like hitting buttons, you'd rather not do more stuff up in the blue and green area, you can. The problem is when you do an exponent, you don't want it only this first 12 from years of savings to be the exponent, and the rest drops down and does times 12 for everything. Does that make sense? You need both of them to be part of what's the exponent. So on my calculator, I have to put parentheses around the 12 times 12 so that the exponent key knows everything after that is in the exponent. Similarly, if I didn't want to do 0.02 divided by 12, I don't have to. But I need parentheses around that part then, so that my exponent will apply to everything and not just this 12 that's sitting there. That makes sense? So for some people, especially if you've had an algebra class, then this might be the nicer way to do things, because you're sort of used to working with longer things, and the idea of plugging a phrase in for one thing isn't as strange to you. But if you like what we did before the computer erased everything, then that's great. Okay, so I will test to make sure that this works. You have parenthesis keys, by the way, on your calculator if you haven't found them yet. So you can just hit them when it says parentheses. $3,812.99. Sounds familiar. I can just do Control S. Okay. Okay, so either way, we now got this. So for the next thing, for part B, oops, I didn't save that. Okay, Well, let's.
It doesn't all
No, it saved what I just wrote. It's just that making it part B it didn't save. So I will grab that, put that there. Okay, now we're on part B finally. So we can get rid of the part A thing. So at the start of the next year, he moves all the money. So the amount we're starting with is the $3,812.99. And he moves that to a different account for 20 years and 4%. Everyone okay with that? This time, the compounding happens quarterly. Last time it was monthly, so we had a whole bunch of stuff that was times 12 and divided by 12. This time it's quarterly, so we need to have, instead of 12s, 4s. The 4% per year, now we only deal out into 4 piles. March, paycheck happens. June, paycheck happens. September, paycheck happens. December, paycheck happens. And each year he just gets 4 of those. Everything is quarters. We're happy. Questions so far? Okay, once we have this, the calculator does all the work. Is it okay if I skip writing the calculator button step? So, 3. I'm getting $8,452.31. Everyone's calculator gets the same.
I'm confused about the 3,812.99 times 1.01. Because then there's that 80 up there was stop
That-
for,
That's the exponent. You do the y to the x key.
and then 80.
80.
Okay.
Yep.
And then 80. Okay.
Do you get why it's 80? Because I just now realized what I had been doing wrong. He has since the beginning of the problem, the first one we did on the section A was yearly, and this one's quarterly. And so you have to think like how many quarters are in a year, and then multiply that by the years. So you're getting, that's how many payments you're getting.
That's why we have the 20 times 4.
Okay.
It's 4 times a year. Top of that gets something in the mail, say stock dividend. because it says at the top, quarterly, so no choice about that.
Pretty much what I do is like, I look at the problem and just figure out right away, like if it's gonna be yearly, monthly, or quarterly, so I don't make the mistake of just like making it years right away.
So when you see something about saving, the first thing to consider is the simple or compound interest. And in this class, it will always be clear, it will have the word simple or compounded somewhere in the problem. And then do your black formula, blue setup, read the problem, put things in the right spot, do the fidgeting you need to do with my green, and then when you plug it in, it should be pretty quick. Okay, so this was what we did actually a week ago, Tuesday of last week.
Can I ask you again?
Sure.
So the final answer, because I did it how I'm understanding.
Got it?
Yeah.
Okay. So we added last class the sum of annuity due formula. So I'm going to go back. And that one I'm not going to steal final exam problems from because we actually have lecture we didn't get to yet. So let's do that. We probably won't finish this today, which is making me lean towards saying no midterm until Tuesday. Is that okay with everybody? Okay. So, sum of annuity due. Neither of these is great for actually saving for retirement. You're certainly not going to buy a bond and wait and when the bond matures try and retire off that. You're not even going to put a bunch of money in the bank when you're 20 years old and then wait 40 years and see what you have. Right? You're going to put money in every year as you save for retirement. And in real life, there's no formula because you're not putting the same amount in every year. You just have to do the math. And we'll get to that kind of thing. But as a next best estimate, as a way to talk about how this works and look at three sisters who have different strategies and get some kind of sense of what counts as retirement savings and what counts as, no, I'm going to be poor and unhappy, then this will be good enough. So the sum of annuity due has a formula that, again, I will have to write out because it has an exponent. So sum of annuity due. Our first thing to notice is it starts with the final amount, the total amount, whatever you want to call it. So in that way it is similar to the compound interest formula. Remember, the simple interest formula just gave you the interest. If you wanted the total, you had to add the principal back. But the others, the final amount, it just spits it all out together. Then it starts out looking pretty simple. Or not simple, similar. We have principal times 1 plus rate. Familiar stuff. And this 1 plus rate, just like before, you probably aren't going to actually put parentheses into your calculator. It's just going to become 1.0 and a number. Then we have times, and we have nested parentheses. And on the screen here, they look like brackets because I can't type giant parentheses. On the board, I'm just going to write giant parentheses. So this is going to be times a 1 plus rate. And the exponent here is years. It's the same thing. It's the number of payouts, except all we're ever going to do with this formula is have years. We never have to worry about months or quarters or all of that other baloney we've had to deal with before.
Is that in the parentheses, is that an R1?
A 1 plus rate up to exponent years.
Okay.
So these, here I'll make my parentheses different colors. When we're done with that part, we're going to subtract 1 and then close our parentheses. That work better? And at the very end, we have a divided by rate. So my big parentheses with sort of a pink highlight to them, those I have to type in to the calculator. I can't escape that. So if you haven't used your parenthesis keys yet, then we're going to learn them in just a moment. A common mistake that people make with this formula is when you get to the end, they divide by 1 plus rate. Since you've just used 1 plus rate twice, you're on a roll, it's sort of stuck its way in your brain, but don't slam the 1 in front of the decimal the last time. It's just the rate. So the formula looks longer, but it's still not bad, and it doesn't have more pieces. It just has the 1 plus rate showing up more often, and a rate by itself. So the blue words will still look just the same. Final amount, principal. Principal is kind of a funny word to use. Before, we've always had principal mean this is the amount we start with, and everything else just builds on it. Whereas principal here means your repeated thing. Every January 1, you're putting in this much money, which is admittedly something that probably should be a different word, but this is what it is. We have our rate, and we have our years.
Could you explain the principle again for this specific example?
Yes, so the story that this equation deals with is every January 1st, we're going to put the same amount of money in our savings, in our investment account. So let me copy all of this, make a new slide, put it there, and then go back and write on it. So how much do you want to save for retirement each year?
5,000.
5,000. Okay. Amazing if you can do that at your age, but
Oh no, I wasn't saying that.
there we go. Yeah. And whoops, I put it in the wrong spot. Here, this is right. It will always be true that you're solving for the final amount. So this one again is a repeated thing. Each year we're putting that in. Okay, what rate are you getting on your investment account? 2%. Not very ambitious.
That's a lot of money.
And how many years are you repeating this thing?
16.
16. Oh, okay. Everyone okay with Amanda's hypothetical example? So we plug it in. The first 1 plus rate is just a 1.02. Now I will need to do times and a parenthesis. I can't escape the parenthesis. And we have a 1.02 with an exponent of 16, and a minus 1, close the parenthesis, and divided by 0.02. So test your calculator wrangling, see if we all get the same answer. Okay, so compared to what we've done before, this is huge. But that's not surprising. The slightly imaginary wealthier version of Amanda put in 80,000 herself, right? 5,000 16 times. So the amount she gained was about 15,000, which isn't bad either. Everyone's calculator gets the same answer? No, let me know. Yeah.
So I did.
Let's see. Yeah. X, yeah.
X, Y,
16.
oh,
Minus 1.
yeah.
Those big things. Divided by 2.
Okay.
And you don't actually need the 0. 0.02 if you don't want.
Okay, I think I forgot that part.
That would mess it up.
Thank you.
If anyone else have trouble with calculator wrangling?
You said these problems, the sum of annuity are always going to be annual.
They're always annual.
What's an annuity mean?
What's annuity? Something I should know, but don't off the top of my head.
I'll Google it later, let you know.
Okay, let's take a little preview about what's happening. Actually, I'll make this bigger since we are reading. Okay.
It's the sum of money paid to someone each year.
So fixed payments each year. Okay.
Yep.
So, saving for retirement. We have 5 minutes. We can talk about the words, and we'll do more examples next time, as well as your homework. So the general rule for retirement savings, if you just talk to investment people, have a financial advisor, read magazines or websites, is at age 65 to have saved $20 for every dollar that your expenses in retirement will exceed your income. Why $20? Because, and that will give you 20 years worth of how much to spend extra compared to your income. You're basically saving to get from 65 to 84. How come you don't run out of money when you're at 84 and your 20 times your extra expenses goes away? Because during these 20 years, you've also been having interest or bonds or things like that, right? So the income during these 20 years will pay for your last years after age 85. A typical American's retirement expenses, how much they spend more than their income, is about $20,000 a year. So if you take this and times 20, people should save on average about $400,000 for retirement. When we say on average, what's the representative person? Well, by then they've paid off their house, they're not putting kids through college, they're just sort of boring and retired. Right? This isn't people that are buying lots of yachts and going on vacations every weekend. This is just sort of a normal American middle class what you're doing. So, we have 3 sisters, Cindy, Clara, and Chloe. And we are imagining, to make the math simple, that every year they're setting aside $3,000. If you look at real life, people don't save $3,000 when they're 25. They save less because they're just getting started in their career. And they save more as they get older. But to make the math simple, to use our sum of annuity due formula, we're just going to be estimating and saying that every year they do $3,000. Cindy puts her $3,000 into savings for 10 years. Which of our 3 formulas is that? You put $3,000 every year into your savings. Some of annuity do, the one we just did, repeated deposits. Then she stops saving. For the final 30 years, she spends it all on vacations, thinking, I'll wait until my kids are older and then we'll enjoy the vacations more. So for the final 30 years, she has whatever is in her savings account and she just watches it grow. So what formula is that? Compound interest, because it's actually going to build year by year. So this is a two-part problem. Sum of annuity due for 10 years, compound interest for 30 years. In contrast, Clara goes on vacations for 10 years, not saving anything. She wants to go on vacation while she's younger. Then, for 30 years, she puts all $3,000 into her savings account. So which formula would that be?
Compound.
Some of it only do. This is the repeating again and again and again. Some of it really do. So she has nothing, no formula for 10 years, and then she does the sum of annuity due for 3,000. Chloe will always go half and half. So the vacation money we ignore. She just has a sum of annuity due for a smaller amount, but for 40 years. Does that make sense? So we'll do that and see. And we're assuming that it's always 8%. The stock market on average historically is about 9%. In real life, you start out with stock market risk when you're younger, and then as you approach retirement, you'd move things into a conservative portfolio without much risk and a much lower gain. But again, to make the math simple, we're just going to use 0.08 for everything. So if you want to work on that before Thursday, you can, but that's where we'll kind of start class on Thursday after asking about homework questions and stuff. You'll find out that the $400,000 they're somewhat close to, some more, some over. Then you would say after this, well, that's all well and good, but where am I going to get $3,000? So we'll look at Cliff. He stops smoking and just spends his pack-a-day money on sum of annuity due retirement. We'll see what he gets. And then we'll talk more. So that's your preview for what's coming next. Any last questions?